Hello, I'm Mr. Malden, and this is the Math Toolbox. Today we are covering proportion problems that involve percent, so really just percent problems, all right? Which we're going to find out just a little bit that it's just another ratio, rates, proportions that involve percent, all right? So let's just kind of dive into this and first just try to understand a little bit what a percent is. When we first start teaching percents, a lot of times we use this tool that you see right there on the screen that I call a 10 by 10 grid, or it's also called a hundreds grid. And the reason why is because if you counted all the squares that are there, there's 100 squares. There's 10 rows of 10 columns, or 10 rows of 10 units in each one. So 10 times 10 is 100. So we use this because we want to try to communicate what a percent is. Percent really is just a conjunction of two words, all right? The word prefix per, which means for every, all right? For every. And then the other word cent, which is a Latin root for 100, all right? How many cents are in a dollar? 100. How many years are in a century? 100 years, all right? So that word cent, it just literally means 100. And so percent really just means for every 100, or parts per 100. And so, the screen that you see right there that has the hundreds grid on it, it has 20 squares that are shaded, all right? And therefore you have 20 parts out of 100 that are shaded. Therefore, that is 20 parts per 100, which is 20%, all right? I always start just trying to use that to kind of help you. But really, it's a concept that these days, anyways, a lot of our students kind of understand what percent is already because your cell phone battery, all right? Right here, you can see there's my cell phone battery. If I, kind of click on it, you'll see that I have 94% left on my phone's battery right there. Well, that means, I've got 94 parts per 100 of the battery, the life of the battery, still left. And, students these days who use devices quite a bit, that kind of helps them understand and kind of give a general understanding of what percent is. And they kind of intuitively, you all kind of intuitively already know that 90% is a higher percent, all right? But once your phone gets down to about 20%, 15, 10%, or especially at 5% or 1%, you're running to find that charger because you want to plug your phone in because you know it's about to die. So you kind of already know by experience what a large percent is and what a small percent is, all right? Well, a complete percent would be obviously 100%. So we use these grids to kind of just start helping us with our understanding. But really, percent is just a ratio, all right? A ratio is a comparison of two numbers. We've been talking a lot about ratios in this video series. You can go back and you can watch the video that I've got on ratios and rates and proportions. But percents is just a ratio. It's a comparison of two numbers where the second number, all right, the whole is 100, all right? So percentage is just a ratio of parts per 100. A ratio can be either a part-to-part ratio or a part-to-whole ratio, all right? Percent is a part-to-whole ratio where the whole is 100. And the number that you see in front of the sign, so if you saw like 20%, all right, this would be the parts. That percent sign would be the per 100, all right? So that's just kind of what it means. And so now, really what we want to do is to be able just to solve problems that involve percent, all right? And 9 times out of 10, whenever we do that, I tell my students to use a percent box. Before we get to that, let's just kind of like maybe understand a couple of these slides right here about percent, all right? What percent of the box or the hundreds grid is shaded, all right? So come up with your answer. You can pause the video if you'd like to. Come back to get the right answer. But the question is, what percent of the box is actually shaded? Well, in order to find this, I'm literally going to count how many boxes are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 boxes out of 100 are shaded, so that is 17%. All right? If I moved on, I look at something like this. You know, what percent of the box is shaded? You should get 60 out of this. And then, therefore, what percent of the box is not shaded? All right? Well, if 60% is shaded, then I just know 40% is not shaded. And the reason why I know that is the whole box is 100 squares. The ones that are shaded are 60. So the ones that are unshaded, if I take 60 away from 100, I find out what the rest is. The unshaded part is going to be 40 boxes, which this is 40 out of 100, so that is 40%. The next one right there you see, you probably already have got your answer. You just kind of hear me talking and rambling on, but you're already moving on to the next answer, which is okay. All right. What percent of the box is shaded? 10% is. Therefore, 90% is not. And for the last one, I'll give you a second to try to figure that out real quick. Okay. That's 55%, all right? So 5 full rows, that's 50% are shaded, and then you've got part of another row, 1, 2, 3, 4, 5 from the other row that's shaded in. So that's 55% that is shaded, which leaves 45% that's not shaded. So 100 minus 55 is 45. So that's kind of how we do that. So but this tool right here, you don't see it a ton, all right? It's just really a tool that we kind of use to try to help our students understand the idea, at least the concept of what percent is. But again, I'd really go back to your experience with a cell phone battery to kind of really lock into the reality of what's a big percent, what's a small percent, and just to, just have a general understanding of percent, right? But let's go ahead and move on. This is the tool that I teach my students for solving percents. And so we're just going to have a basic question right here. What is 30% of 80? Whenever you see that word percent or the symbol percent, so you see a symbol percent or you see the word percent, I want you to get in the habit of just like knowing that this tool exists, of thinking about a percent box, okay? Unless you see the words increase or decrease or interest. If you see those words, this is probably going to be a different kind of problem. We'll talk about that in the coming weeks when we get there. But if you don't see those words increase, decrease, or interest, probably a percent box is going to be a really good tool to be able to help you figure that out. So let me just show you really quickly how to draw the percent box. So again, we've seen the percent sign, we've seen the word percent, we don't see the words increase, decrease, or interest. All right, I want to draw a percent box. So I'm going to start out by just drawing a box, just like that. And then I'm going to separate this box into 4 equal parts. And I've got 4 places for numbers right here. Now here comes my little spiel about tools and more useful tools, all right? If you were tasked with going to the woods to chop down some trees, the tool that you'd take with you is an axe or a chainsaw, all right? But it'd be really helpful for you to take that axe or that chainsaw and go sharpen it first before you go out to try to cut down some trees, because it's going to help you get it done faster. Well, in the same way, this tool that I'm teaching you, the percent box, all right, this is called a percent box. I'm going to write that up there. All right, this percent box is a tool, and there's a way that you can make this really sharp, and it's like this. I'm going to write the word is up in the top left corner of the first one, then percent of, and then a big 100, just like that. So I'm making my tool a sharp tool, and now it's a tool that'll help me work through the problem. Like whenever I see that word percent or the symbol percent, I draw a percent box, all right? Unless I see the words increase, decrease, or interest. And then I allow the percent box to walk me through the problem, all right? I don't know if you're like I am, but when I was in 7th grade, middle school, I really hated word problems. I wasn't very good at reading at that point. I really loved math, but I wasn't, really great with reading comprehension. And so I needed things, even in that time, that could kind of help me walk me through the problem. Well, that's what these tools do, all right? On my channel, you're going to learn intermittently throughout all the different lessons. You're going to learn some different tools that I teach my students. Well, one of them is the percent box, and the reason why is it helps diffuse like the the trouble of a word problem. Once you know what tool to use, you can let that tool kind of walk you through the word problem. I'm going to show you how to do that. But that's how to draw the percent box. Put a box, separate it into 4 equal parts, then write is, percent of, and then a big 100 right there. That's how you're going to draw that. All right, now let me show you kind of how you're going to use that with this little scenario right here. What is 30% of 80? All right. The first number that I'm trying to put in this box, all right, usually there's a dead giveaway inside the problem. You'll see this percent sign, all right? If you ever see a number, by the way, let me just take a step back. Percent problems, all right? Let me take it even a step back from there. Ratio problems, all right? Ratio and proportion problems. They usually give you 3 numbers, and they're asking you to do something with those 3 numbers to be able to find a 4th number, all right? Percent problems, like I said, percent's a ratio, so they're really similar. But percent problems will always only ever give you 2 numbers because they expect you to know a 3rd number that you bring to the table in order to be able to find the 4th number. All right? So this problem right here says, what is 30% of 80? Well, it's giving you 2 numbers. 30 and 80, all right? But they expect you to know a 3rd number. And the number that they'll always expect you to know is what is a whole percent, all right? The whole percent is 100. It always has been 100. It always will be 100. You never have to guess about that. A whole percent, a complete percent is 100%. Have you ever had somebody tell you, like, I want you to give 100% of your effort? Imagine you have, all right? What they're saying is, give it all you got, all right? Give it everything, because 100% is a whole, is everything, all right? So they expect you to know that number. Now then, the 2 numbers that you're given can go in any one of these 3 boxes right here. So they're going to give you 2 numbers, but your task is to try to figure out, is it my part or my whole, or is it my part percent, all right? So which boxes do these 2 numbers go in? So they don't always go in the same boxes. So there's some clues from the problem, and the clues have to do with these words, is and of, and then that symbol percent sign. All right. So the first one that I'm always looking for is that percent sign, or the word percent. All right. Now, if it said what percent, well, we don't know what the percent is, and so that would be what we're finding. But in this problem right here, it says, what is 30%? So the percent here is 30. Big word problems, usually they don't write the word percent out unless that's what you're trying to find. They would write it out like this inside the problem. You'd see that symbol, and that number that's next to it, that's the number that's going into the part percent box right up there. All right? Then I said, what is 30% of 80? All right? 80 in this thinking is our whole number. All right? And it comes right after the word of. Most of the time, if you see the word of in a problem, all right, the number that comes after it is going to be the number that you're going to be putting in that box right there, all right? Or after the word of, they may give you a word. So of the tools, how many of them are a hammer? Or what percent are hammers? Well, of the tools, we got to find out how many tools there are, and the word problem is probably going to tell us, there's 15 tools and there's 3 hammers, something like that. What percent? So after the word of, you're going to see a number, and that number generally would go there. But sometimes the of is not helpful. Sometimes the is not helpful, and so you always want to kind of revert to this. This part whole thinking is what I try to teach my students as well, all right, is that the top row has to do with part, the bottom row has to do with whole, which is why we put the 100 down here, because it is a whole percent, all right? But once we get them put inside here, we solve this just like we would solve a proportion problem, all right? You can either find a scale factor, all right, there's a nice easy peasy scale factor, or you can always cross multiply and divide by the 3rd number. So the numbers that are diagonal from each other, you would multiply those numbers, all right? So we've got 80 times 30, that equals 2,400, and then we're going to divide by the 3rd number, which is 100.
Mr. Malden?
All right. Sorry about that. I had somebody interrupt the class. No big deal. All right. So the answer would be 24. So 24 is 30% of 80. All right. So let's go ahead And you can see the illustrations here. I did it on my board so you can see it there. But let's move on to another problem. All right. In one particular suburb, 80% of families with dogs own a boxer. If there are a total of 15 families in this neighborhood with dogs, then how many own a boxer? All right. Well, we have a problem here, and I'm wondering what to do with it. But I see this percent symbol, all right, and I'm going to remember that Mr. Malden told me that whenever I see the percent symbol, my first inclination should be to use a percent box, all right? That's a great tool to use, all right, because I'm going to set up a proportion here inside these little boxes right here. And I don't see the words increase, decrease, or interest, all right? That's going to be a different kind of problem. You can use a percent box technically for those, but there's a more straightforward way to do it, all right? So reserve a percent box for those percent problems that don't involve percent increase or decrease and don't involve interest or finding interest, all right? So we've got our percent box, and I'm going to make it sharp, is percent of 100, just like that. All right, then I'm going to look for that percent sign in the problem. I see it. It's right there, that 80%. So that number is going to go right there. All right, just like that. And then I'm going to look for an is or of in the problem. Like sometimes I said, so it's there, sometimes it's not, and sometimes it's helpful, and sometimes it's not. But in this case, it is kind of helpful, all right? We see the of in two places. We see of families with dogs, all right? Of families, some of them own boxers. And then after this of over here, you see the number 15. And that 15 is families that have dogs. That's a total, all right? So that 15 is going to go right there, all right? So all the families in that neighborhood that have dogs, there's 15 of them. And part of that number have a boxer. And that's what we're trying to find right here, all right? So we're trying to find the part that have boxers. So then we put it in our percent box just like this, and we're just going to solve this, we're going to cross multiply. So I'm going to multiply 80 times 15, the two numbers that are diagonal from each other, just like that. And then I'm going to divide by 100. All right, and I'm going to find out that 80% of 15 is 12. All right, that's my answer, just like that. So once you fill in the percent box, you'll cross multiply and divide. All right. Try this next one, all right? I want you to go ahead and pause this video and you try it yourself and then come back to see what the answer is, all right? So go ahead and pause the video. All right, it says one baseball team played 15 games throughout their entire season. If this baseball team won 9 of those games, what percent of the games did they win? All right, well, I see the keyword percent right there. I don't see the words increase, decrease, or interest, and so I'm going to draw a percent box just like this. Is percent of 100. Now then, the problem asks what percent. So I don't know the percent right now, so this is going to be my x, all right? Now then, when we don't know what the percent is, and that's what we're trying to find, 99 times out of 100, the two numbers they gave us, the small one's going to go on top and the big one's going to go on bottom, all right? Because the top is a part and the bottom is a whole. And usually when we're talking about percentages, we're talking about a part of a whole, less than one whole. So we put the small number on top and the big number on bottom, which is really, that's just a fraction, okay? It's 9/15 as a fraction, and that'll simplify down to 3/5, all right? Which if you know your standard benchmark, fractions, decimals, and percents, you know that 3/5 equals 60%, all right? But if you don't know that, we'll go ahead and solve it out, all right? So now we've got the percent box filled in. Now we're gonna put in 9 times 100, and we're going to divide that by the other number 15, and we're going to get 60. X equals 60%. So of the baseball games that they played, it said they won 9 of them. That's 60%. This team is on track to win about 60% of their games. All right? All right, let's try another one. Go ahead and pause the video, and then you can try this one, and you can come back to see what the answer is. It says a concert hall has 400 seats, of which 325 are occupied. What percent of the concert hall is occupied? Again, we're trying to find the percent. I see the keyword percent, so I'm going to write my percent box just like that, all right? And then I'm going to look at my two numbers. Now I don't know what the percent is, so that's going to be, and I don't see a percent symbol in that problem, so that box right here is going to be blank. That's going to be what we're trying to find. And then I have the two numbers left. Now first level thinking, small number goes on top, big number goes on bottom. Second level thinking, I'm looking for an is or an of, which I see an of in the problem, but it's kind of confusing. All right, it says a concert hall has 400 seats, of which 325 are occupied. Well, I just said a while ago that usually the number that comes after the word of is your of, but in this case right here, the problem says of which, of what? Of what? Of the 400 seats. So that of is referring to the 400 seats. And then we want to think about the third level thinking, which is part, whole reasoning, all right? We're just kind of checking ourselves to make sure that we put those numbers in the right place, all right? Part, whole thinking, okay? Well, does that 400 represent all the seats that are in this venue? It does, all right? And 325 represents the part that's already filled, that's already occupied, all right? And so you've got that one as your top number, all right? So you want to kind of use kind of all of those thinkings to be able to ensure that you're getting the right numbers in the right place. Then once we have the right numbers in the right place, it's as simple as cross multiplying 325 times 100, all right? And then dividing by the third number. Divided by 400, and you're going to find out that the percent of the seats that are occupied is 81.25%. All right. Well, that wraps up the lesson. There's some more word problems we could go through, but I think you kind of get the gist. If you have any questions, you can put that in the comments down below. I hope you have a great day.